We're finishing up section 17 with inequalities and absolute value. So what we're going to start doing is not just solve absolute value, but we want to solve for all values in this. So just starting out, and hopefully you already did the previous lesson, because what we did is we set what's inside the absolute value equal to 2, but then we also set what was inside the absolute value equal to -2. And so as you add the 5 over, we got an answer of 7, as well as the answer of -2 plus 5 is 3. And so what we didn't do is we found other possibilities. So for instance, let's just guess for a second, let x equal 4 for a second. Well, if you do that, 4 minus 5, I'm looking at this inequality. Well, I guess technically what I'm looking at is right here, because 4 minus 5 is -1, and the absolute value of -1 is equal to +1, and it is still true that 1 is less than or equal to 2. So x equals 4 is also a solution. And so the thought process is, what you could do is you could draw a number line, and we really only care about 3 and 7. Why do I only care about 3 and 7? Is because of the answers I got in part A. But then there's this thought process that we can plug in random numbers like x equals 4, which I did earlier, and that worked. But then I could plug in a number that is bigger than 7. So I guess right there would be my stipulation I'm looking at. I don't really like that was written that way. Like x equals 8. Well, if I plug that in, 8 minus 5 is 3, and the absolute value of 3 is still 3, is not less than or equal to 2. So that does not work. And I can do the same thing for values that are smaller than 3. Let's say x equals 0. Well, 0 minus 5 is -5. The absolute value of -5 is +5, is not less than or equal to 2, so that did not work. So there's a couple ways that we can write our generalized solution. It's because we wanted all the answers, we tried that way, we tried in between, and the ones that worked were the ones that were in between 3 and 7. So in set builder notation, what we would write is we want values for x satisfying that our answers were between 3, and I want to use or equal to because we had an or equal to up here. X is less than or equal to 7. And I guess I kind of already gave my number line representation over there, but I can go ahead and redraw it as well. A lot of times I like to see 0 on your number line. 1, 2, 3, 4, 5, 6, 7. And what we do is we fill in our circles, and we want the answers in between. And maybe one more time before I move on, sometimes you'll see me write this in interval notation, which you should remember from a previous lesson. We're going from 3 to 7. So we can do the same thing, and there, for whatever reason, they want to stick with set builder notation. But what happens is we can have values for that are bigger than 11, and here's my thought process, is if I change the sign of 11 to be -11, then you have to flip the inequality. And it's because what you're technically doing is you're dividing by -1, and when you divide by a negative, you have to flip that inequality. But let's go back to green and go ahead and solve this. 2x plus, you add the 1 over to get 12, so x is greater than or equal to 6 when you divide. Whereas on this one, you add 1 to -11, you get -10, and when you divide by 2, you get -5. So the correct answer on this one would look like this. So again, I like to write out 0 somewhere on there. -5 would be this way, 1, 2, 3, 4, 5. It's filled in because it was an or equal to up here, but we wanted numbers that way, and then 1, 2, 3, 4, 5, 6. Greater than or equal to would be that way. And in set builder notation, how about this? Because I'm running out of room. We could write it like this. Or, there you go. So I'm going to circle all of this. And maybe I'll also talk about interval notation, because you could see it in interval notation written this way. We want values from negative infinity to negative 5 with a bracket, union 6 to infinity. I'm a big fan of interval notation. So what's different with the next one is that we need to isolate the absolute value first. So what I mean by that is you need to subtract the 3 first to absolute value of x minus 4. That would be 16. And then when you divide both sides by 2, we want it less than 8. So as I rewrite this problem, it's okay for x minus 4 to be less than 8. But then we also need to make sure that x minus 4 is greater than negative 8. So as we solve this, add 4 over, we get 12. But then on the other one, as I add 4 over, I need to be bigger than negative 4. Negative 8 plus 4 is negative 4. So the way I would write this in set builder notation would be values for x that we are bigger than negative 4, but smaller than 12. Just like that. I get why they don't want you to write it in interval notation, because in interval notation it just looks like an ordered pair. Notice that I dropped the or equal to because it was not equal to right there. And then on a number line, we would see an answer that looks something like this. Again, I like to see 0. You don't have to. Maybe I'll count by 2's. From negative 4, 2, 4, 6, 8, 10, 12. And we want values between. Notice that that's an and statement. And over here we had an or statement. And there's a big difference between those two. I don't think I want to stress them too much. I just want you to recognize we have an and statement when we want to connect points, but we have an or statement when we want to be on the outside. So let's see if we can come up with this last exercise 3. And the reason why it's an or statement is if we're bigger than 10, on the flip side, we would be smaller than negative 10. So as I add 6 over, definitely getting 16, but that's not really helpful because we can see that there's a lot of answers that have 16 on them. But we want to be bigger than 16, so that's going to cross off option 1. I don't know how thick it is on your piece of paper, but this one's supposed to be between, this one's supposed to be between. So 1 and 2 are bad options. And if I finish over here and I add 6 over, I get x is less than negative 4, which brings me to option 4 being the correct one. So on the next one, this one's a little bit trickier, but you can do the same thing. X is less than or equal to x plus 8. And then we also have this statement, and I'm just going to write it as or for right now. The negative, because what's inside the absolute value could be negative, is less than or equal to x plus 8. So we have an issue with that first one because as I subtract over, I don't get any points to check out. Okay, that's not helpful. 0 is always less than or equal to 8. But on this other one, if I subtract x over, I get negative 2x is less than or equal to 8. And if I divide the negative 2 over, I get x is greater than or equal to negative 4. Well, let's see what happens there. So let's look at our number line. So right here, 0, 2, 3, negative 4. It could equal, but let's try some different values. Let's try a number like x equals negative 5. So absolute value of negative 5 will make that positive 5. I'll write it right here. And then negative 5 plus 8 is negative 1. Is 5 less than or equal to negative 1? No. So we don't want answers, maybe instead of an x, I'll put no right there. But what if I try a number like x equals 0? Because that's to the right. Well, absolute value of 0 is 0. Is 0 less than or equal to 0 plus 8? Yes. So our final answer is correct, that I chose values that are bigger than, and I think this is good to practice writing the answer this way, plugging in numbers, making sure that you have the right answer. And this time they do want the answer in interval notation, so let's practice that, going from -4 and infinitely to the right. And that's something we can talk more about in class. Excuse me. So if I do the next one the same way, I could have this inequality, but I could also have the inequality where I negate everything, because what's inside of that could be a negative. Anyway, let's do the first one. If I subtract x over, I'll cancel that x, but I could also subtract 11 over, so I'd have x is greater than 8. Okay, not sure if that's the right answer, but let's stick with it for a second. In this one, I want to distribute that negative as well as subtract an x over, to cancel that out. So negative 2x minus x would be negative 3x. But this time it's negative 11 that I have to add 11 over. So that's now greater than 19 plus 11 is 30. And if I divide by negative 3, I'm guessing my final answer is going to be less than negative 10. Well, let's see on a number line. So we have 0 somewhere in the middle, we have 8 over here, we got negative 10 over here. Let's see if numbers work if I go to the left of negative 10. Let's say negative 20, just an obnoxious number. 2 times negative 20 is negative 40, plus 11 is negative 31. The absolute value would make that positive 31. Negative 20 plus 19 is negative 1. Is it true that 31 is greater than negative 1? Yes. So I do want answers that way. What about x equals 0? Well, 0 plus 11 is 11. Is 11 greater than 19? No. So we don't want answers there. But let's try an answer like x equals positive 20. That's definitely bigger than 8. So now it's 40 plus 11 is 51. Is that bigger than 39? 20 plus 19? Yeah. So my inequalities were correct. This is the right answer, but then we also have to write it in interval notation. So I would write from negative infinity to negative 10 with a parenthesis because it's not equal to union 8 to infinity. So those are your final answers. And then we can also look at this on an XY graph, doing very similar things. And so with a calculator, I could type this in. Hopefully I can do this quickly. Y equals absolute value of x minus 4. So that's going to be my blue graph. And then the other one is negative 1/2 x. I'm just going to write 0.5x for save me some time, plus 5. So if I go to the graph, I can see that and that. And what I'm looking for is, maybe I'll even do this in blue. So I'm running out of time. That's this curve. And then the red curve, I have that wonky looking thing. Looks something like that. And what we need are the points of intersection. So if I use my graphing calculator, hit second, trace, the fifth option is the intersect. I want to go to the left here, enter, enter, enter. So negative 2, 6. And then do the same thing. Just move the cursor over, enter, enter, enter. 6, 2. Ooh, that is a poorly drawn graph. But stick with me, because now we have that, we have that. We are asking the question, where is the blue curve greater than the red curve? I think it's pretty clear, and if not, we can talk about it. From negative infinity to negative 2, that blue line was above, but between negative 2 and 6, it was not. And we're using parentheses because it's not or equal to, but then from 6 to infinity. bring your questions.